Hi everyone, in this recording we'll discuss small multiples and faceting. So remember earlier I'd given an example where you have lots and lots of good news and then it just got worse and worse. Right? The good news was that there's so many kinds of visual encodings that are available. Right? You can do location, you can do color, do size. But then the bad news was that our eyes are actually only that good at working with a few encodings at a time. The encodings can interfere with one another. You really have to prioritize what you want people to pay attention to. So it seemed like even though at first there might have been many encodings we could have used, our options for visualization might seem kind of limited. It turns out that's only part of the story. Right? The more complete idea is going to be that some of the encodings that I mentioned as being effective, they can be deployed in ways that are not obvious at first. Right? Like it's obvious that you can use location to encode position of circles and squares, right? That's clear. But that you can use location to encode information where the marks are entire time series, and that's a very creative idea. And that's kind of the one of many extensions that makes data visualization a very rich field. So let's look at faceting and small multiples in detail. The basic idea is very simple. The basic idea is that our eyes are actually pretty good at looking at lots and lots of parallel plots as long as they're structured in the same way. So you can imagine a newspaper page with all these little time series. And even though each individual time series is very small, you can make out the essential patterns very quickly. Right? You can tell pretty easily that these are clustered, they have similar shape. Our eyes immediately notice this jump. Right? We notice these are increasing, right? So, okay, this idea of making parallel, lots of small plots, that is the small multiples idea. So how do we make small multiples in ggplot? There are two commands that are useful. One is facet wrap, and the other is facet grid. Let's look at an example using the Gapminder dataset from before. I filtered to just a few years, 2 continents. I'm showing fertility versus life expectancy, but changing over time. So this is exactly the same small multiples idea. Instead of little lines, I'm showing little scatter plots. And they're showing how they've changed from 1962 to 2012, these two variables. Okay, all we had to do, we had to add this new layer called the facet layer. The dot means, it means on the X, you just have, you don't vary anything, right? It's saying along the Y columns, this axis, have the year variable. Right? If I had done year tilde dot, it would have stacked the years on top of each other. Okay, that's the basic idea about faceting. It's going to create plots where the rest of the encodings, like the geom point encoding, within each facet, it's using whatever was in AES, but it's going to repeat that across each of the facets. Okay, so yeah, I mentioned that this one is doing it along the columns. If I had switched the order, it's doing it along rows. You can facet by several variables at once, right? So here I'm faceting by both year and continent. So you can see where they all started off in 1962. And you can track changes within each of the continents. The way I did it is I now have on both sides of the tilde. Okay. There's actually quite a bit more syntax you can do. You can do dot tilde continent plus year, switch it. You can do 3 variables at once. I encourage you to play around and just get a feel for what Facet Grid allows you to do. Okay. So Facet Grid is going to always put the same variable all along the same row. Sometimes you don't actually need them to be fixed to the same row. So, for example, here I'm showing year, and it's continuing on, it's wrapping onto the next row. How do I do that? Instead of using Facet Grid, I just use Facet Wrap. So the notation makes sense. Okay, so we saw it for scatterplot. This idea is actually very, very general. I'm going to show you another example where it's line plots. So this is a data set it's a microbiome data set, 5 different bacteria, you're tracking them over time for 3 different subjects. everybody gets antibiotics, so it's going to cause some havoc on their microbiomes. So let's look. So in each plot, I'm giving a line layer and a point layer. The points are which antibiotic phase they're getting as a color. The x-axis is time, and that's shared across all the layers. The y-axis is the abundance each of these U and C. These are different species. The line is a smoothed value that I computed ahead of time, and y for the points, these are the true values, right? So the black line is smoothed from what the little points are. The main point I want to show you, though, is that I've repeated that plot across all species-person combinations by using Facet Grid. Whatever was on the right-hand side, that becomes columns. So D, E, and F are IDs for 3 different people. Whatever was on the left-hand side of the tilde, these are all the different species. Now, some of the species are very abundant, others are quite rare. So like these are very rare. You can try sometimes to change the scale within each group. It's always a very tricky decision to make because sometimes people will misread it. If you allow the scales to be different across each group, a lot of the times people won't actually read the labels. So be very careful before you do this, but in some cases it does make the plot a little bit more informative. So here I've made the same kind of plot, but I've changed the Y scales so that they can be free within each group of each horizontal group. I think it's actually a little bit more readable. You can see the effect of the antibiotics, where before it had just been almost looking like a flat line. The way I accomplish this is I passed in this free here, free underscore y for the scale. You could do free underscore x if it had been, if you wanted these to be free. Okay, and unlike time, these are being sorted alphabetically, which is not that meaningful. Time, it made sense when it's sorted by time because that's the ordering that you want to see the panels. Here we have some freedom. We get to choose in what order do we see the species. You also have some freedom over what order you see the people. Here I'm going to reorder the species so that it goes from the most abundant to the least abundant. How can you do that? It's very straightforward. Remember the reorder command that we used for population in the bar chart? We can also use reorder to order the facets in a faceted plot. Here I'm reordering the species by their average value. So it's going from relatively less abundant to the now very abundant species.